Hi, this is Lab 4 for Physics 2211. In this lab we're studying a spring mass system as it oscillates. In this lab we'll be used two basic principles, Newton's second law and the energy principle. Newton's second law will be used to help us observe the motion of the mass and plot the computational model of the mass and its spring system. After this is computed, the energy principle will be studied through a graphical analysis at the end. Delta E equals delta K plus delta U of the spring plus delta U of gravity. So we'll show that in a graphical analysis at the end of the lab. We track the mass in Tracker. We set the calibration stick to the spring from the fixed hanging point at 0.7 meters right here as the spring is at rest. Then we set our axes as the origin at the fixed hanging spot, and we just continue to track the mass here, as you can see. So Tracker gave us a table that looks a lot like this, and we will take the x and y values that we got from the Tracker we're going to plug those into an Excel file and save it as a .csv, which will be implanted into our coding, and will give the actual model the position points it needs to show. So we put Newton's second law into our coding here with the forces needed. F grav is just the ball's mass times the gravitational constant in the negative y direction. The spring mass is negative ks times the compression of the spring times L hat, which is the direction of the force, and F net is just the sum of both of those forces. And this is what's going to give us the new points in our calculated model. It gives us the new velocity and the ball's position using the F net provided. Now, before we can continue with the F net, we need to define Ks, S, and L hat so we can actually use these values. So for our F net to work, we calculated this spring information. L is just the stretch of the spring, so the ball position minus the spring position. L hat's the direction of the spring force, so the L over the magnitude of L, and then S is just the mag of L minus L naught to give us the compression of the spring. So when we run our code, we should see what looks like the spring oscillating. You can see the black arrow is the gravitational force, the blue arrow is the spring force, and the yellow arrow right here is F net. So in order to see our energy principle in action, we code our energy changes in here. So we have kinetic energy calculated here, and delta K is just the initial kinetic energy, and well, the new kinetic energy minus the initial kinetic energy. And the same follows for the other, the potential gravitational energy and the potential spring energy. And delta UG is just the new one minus the initial, and same with spring. This will be shown in the graphical analysis at the end of the computational model. So because there are no outside energies or forces acting on our system, the delta E should technically be equal to 0. So we can see here that the red line, which represents the spring potential energy, the blue line represents the change in kinetic energy, and the green line represents change in the gravitational potential energy. And then the yellow line, which follows along the axis at 0 here, is the addition of all of these lines together, and you can see that it is equal to 0, so our energy principle is proven to be true. So as we just saw, the energy principle is satisfied as delta E equals 0, and we saw that in the graphical analysis that Python spit out for us. I've calculated an oscillating period based on the x-axis and the y-axis. We can see that the x-axis oscillating period is 1.68 seconds and the y-axis is 1.55 seconds. Why is it different? F net affects the system differently in the x and y directions. Gravity affects y but not x, so that makes these oscillating periods different.